I'm going to preface this video by saying I am doing laundry, so you might hear the machine in the background. So, just giving that warning. All right, so we're going to look at antiderivatives. All right, and I already see a little typo here. I don't need a slash here. So, a function, big F of x, is an antiderivative of a function, little f of x, if the derivative of big F of x is the same as the original function, little f of x, for all x in the domain of f. And the process of finding an antiderivative is called antidifferentiation, right? Think about derivatives, and we call that process differentiation. So if we want to find antiderivatives, it'd be antidifferentiation. Okay, the family of all antiderivatives of a function is the indefinite integral of f with respect to x, and is denoted with this symbol here. So I call it like a fancy S. That's the integral symbol of f of x dx. And then if big F is any function such that the derivative of big F is little f of x, then that integral, right, is big F of x plus c. And that's called the general solution. And that plus c is called the constant of integration, or an arbitrary constant. Because think of it like this. If I have x squared plus 2, right, now I find a derivative, that's going to give me 2x. And then that plus 2 goes to 0, right? So if I want to go backwards and I want to say, all right, here's a function, and I want to find the original and do that antiderivative, I don't know what that number is. So I can go from 2x down to the x squared, but I need to know, the constant that was there. And so I'd have to put a plus c so that it puts a placeholder there for us. All right, so let's kind of look. So we know that if a function f has an antiderivative, then there's a family of functions that share the same derivative. And then the antiderivatives only differ in the c. So state three functions whose derivatives are 3x squared. So that would be x cubed plus 1, right? Because that derivative would give 3x squared. We could have x cubed minus 4. Then we could also have x cubed plus, 7. So they only differ in that plus c. So what is that meaning of that plus c? That's the vertical shifting, right? So if I'm thinking x cubed, it looks something like this. And if I add or subtract numbers, it's the same function, just shifted, right? Up or down. All right. So the expression is read as the antiderivative of f with respect to x. So we can think of it like this. That's kind of how I like to solve it. So we have dy over dx is the derivative. It's almost like I want to separate the variables. So I want to put x on the other side, so I'll multiply both sides by dx. So I have dy equals f of x dx. And then to, in a sense, like get rid of that dy and that dx, we would integrate both sides. And then the integral of dy is just y. And then the integral of f of x dx is the antiderivative and then plus c, right? So here's just the general antiderivative, kind of like that notation here. I'll just that's the integral symbol. The f of x part is what we're integrating, so it's called the integrand. And dx is our variable of integration. Big F of x is the antiderivative, and plus c is just an arbitrary constant. Right, so before we look at all the different rules, let's see if we can kind of rewrite some of these and kind of deduce them ourselves. Because the big thing with integration is going to be all the different tips and tricks. In fact, Calc 2 is almost a whole course on that. So we might want to rewrite some of them. That might be one trick. So I might rewrite this. So I don't think I can do anything with the 5e to the t. But I think 1 over cosine squared of t could be written different. Maybe secant squared of t dt. And then let's just think kind of backwards. So what would give us a derivative of 5e to the t? This one's a little easier because e to the t, the derivative is just e to the t, and 5 is just that multiplier. So it's actually just 5e to the t. And then what gives us a derivative of secant squared? That's going to be tangent. And then we just won't forget our plus c. All right, until we learn substitution, which is a lesson for another day, we might have to actually multiply some things out. So 3x minus 1 squared is going to give us 9x squared minus 6x plus 1. And then let's try and think, what is going to give us a derivative of 9x squared? So I know it's going to be some form of x cubed to give us that x squared. And then I'd have to have a number here to give us 9. So 3 times 3 is 9. And then 6x will have to have some form of x squared. And then it's got to multiply to 6. And then a derivative of just 1 would be just x. And then plus c. It might be helpful to separate fractions. So let's separate it and simplify. So I'd have x squared over x to the 5th, which will leave me with x to the negative 3. And then we have 4x to the negative 4 and 5x to the negative 5 dx. And let's think the same thing. So I want what would give me a derivative of x to the negative 3. So we'd have negative 2. And then, let's see, I want the number out front to be 1. So I probably have to divide it by negative 2. And then, let's see, we have 4x, see, negative 3. And then I probably have to divide that by negative 3 as well. And then that last one, we'd have x to the negative 4. And then probably have to divide by that negative 4 as well, so that it cancels out. And then plus c. And then maybe we have to do multiple things. So maybe we have to multiply out and simplify. So I'll do some side work here. We get x minus 3 squared. This is going to give x squared minus 6x plus 9. And then it's all divided by x to the 1/2. I can use some exponent rules there. So we have, let's see, 2 minus a half is 1 1/2, so 3 halves. 1 minus a half is just 1/2. And then we have 9x to the negative 1/2. And then I'll try and do some rules here again. So let's see. I want a derivative of x to 3 halves. So let's see, 5 halves. And then I want to cancel out the constant to be 1, so I probably need to multiply that by 2/5. And then we have, let's see, x to the 1/2. So I'd have 3 halves. And then I'd want to multiply by 2/3. And then let's see what happens here, because I want it to reduce down to 6. So maybe 4. And then see, 1/2, and then probably 18, because 18 times a half would be 9. All right, and don't get caught up on if you can't think, oh, what's going to give me a derivative of this? Because right now we're going to go into the basic rules. Okay. So I have both the left side as the derivative rules, and then the right side are the integration rules. Okay. So I'll go through some of these. So if we have nothing here, then when we do the integral, we get just c. If we have just a constant, we have kx plus c. If we have a constant times a function, we can pull the constant out and then do the integral as normal. If we have multiple functions being added or subtracted, we could separate each one out and add or subtract them. All right, the power rule. So think, for derivatives, if we had x squared, we do the derivative by pulling the number out and then subtracting 1 from the power. So we have to undo that. So instead of subtracting 1 from the power, we're going to add 1 to the power. And then we're going to divide by that new power. So I'm going to go from 2x, and I'll go backwards to that x squared. So I'm going to add 1 to the power. So 1 plus 1 is 2. And then I'm going to divide by that new power. So I'm going to divide by 2. And then the 2's will cancel out, and I'm left with that x squared. Right? The only time that power rule doesn't work is if we have x to the negative 1, or 1 over x. That's a different rule. I won't read all of these out, but here are the trig rules, right? I'll do the basic one. So cosine, the integral is sine. Sine of x is negative cosine. And secant squared is tangent. Okay. Now here's the log and exponential. So e to the x is just e to the x. When we do the derivative of any other exponential, right, it's the original function and then times natural log of the base. So we have to undo it. So instead of multiplying by the natural log of the base, we'll divide by the natural log of the base. And then here's where that 1 over x, that power rule is not going to work, because if we did that, so it's x to negative 1, right? If we add 1 to the power, we get 0, and then divide by 0, and we can't divide by 0. So this is where natural log comes in. So it's natural log of the absolute value of x, because remember, we can't take the log of a negative number. All right, so that's the basic rules, and we're going to apply some of them here in just a moment. But we have something else we're going to do as well. I'm just going to add another piece to it. So normally when we're integrating these indefinite ones, right, we get an antiderivative, and then we have plus c. Well, we can find the specific solution, and we can find what that c value is if we are given an initial condition, or if we're given more information. So doing that is called solving differential equations. And if you love that so much, there's a whole course on differential equations. Okay, so we have a derivative here, 2x minus 1, and then we have an initial condition, f of 2 is 5. So let's solve the differential equation. So we are going to integrate both sides here. Go here and here, make a dx. So the integral of a derivative is just the original function, which can be y, or we can make that just f of x. And then let's use our power rules. So 2x, add 1 to the power, divide by the new power. And then add 1 to the power, divide by the new power. And then we normally put plus c. I'm going to simplify in the next step, but I know that f of 2 is 5. So let's plug that in. That 2 over 2 will cancel, so I have x squared. And then all of that just cancels out, just be x. So let's see what we have here. So 2 squared is 4. 4 minus 2 is 2. And then I can solve this, and c is 3. So my original function, or my specific solution, is going to be x squared minus x plus 3. Let's do a trig one here. So we'll integrate both sides, right? So I get f of x. 2 is a multiplier, right? So I could pull that out and make that 2 times the integral of cosine of x dx. And that's going to give me 2 sine of x plus c. And then f of pi over 2 is -3. So -3 equals 2 times sine of pi over 2 plus c. Think unit circle, pi over 2 is the vertical one, sine is y, so y is 1. 1 times 2 is 2. And then subtract 2 on both sides, and c is -5. So our function is 2 sine of x minus 5. Sometimes I'll throw parentheses around the x so that that -5 doesn't look like it's with the sine function. All right, do some more polynomials here. So we'll integrate both sides, and we get f of x equals, to power rule, add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, and add 1 to the power and divide by the new power. And then we have plus c. And now I can solve. So 1 equals 3 cubed divided by 3 plus 3 squared divided by 2 minus 7 times 3. Let's see, 3 cubed is 27. 27 divided by 3 is 9. And then we have 9 over 2 and 21. I am a fractions person. Fractions are friends is what I like to say. And I'm going to make everything out of 2's. It's going to be 18 out of 2. And then we'll leave that. And then we'll make that 42 out of 2. And then we'll combine some like terms. So we have 18 plus 9 minus 42. So that gives me a -15 over 2. Add to both sides, so I get 17 over 2 is c. So my original function is x cubed over 3 plus x squared over 2 minus 7x plus 17 over 2. And now you can rewrite those as 1/3 x cubed and then 1/2 x squared. It's the same thing. Let's do another polynomial here. So we'll integrate both sides, and we get f of x is 3x cubed over 3 minus 4x squared over 2 plus 2x plus c. And then we'll solve. So -4 equals, and I'll simplify here. So those 3's will cancel out. I'm just left with x cubed. So -1 cubed. 4 and 2 cancel out to be 2. And then let's see what we get here. So -1, -2, -2. So was that -5? So c is going to be 1. So our original function is x cubed minus 2x squared plus 2x plus 1. All right, just 2 more here. I might rewrite that to be t to the 1/2. And let's use that power rule here when we integrate both sides. So we'll get g of t. And the fraction ones are kind of weird, right? Because we can add 1 to the power. So 1/2 plus 1 gives me 3 over 2. But then when we divide by the new power, so divide by 3/2, we divide by a fraction, we're really multiplying by the reciprocal. So really we have t to the 3/2, and then we're multiplying by 2/3 instead, right? Then I can solve. I don't know 9 cubed off the top of my head, but I do know the square root of 9. Square root of 9 is 3. 3 cubed is 27. 27 divided by 3 is 9. 9 times 2 is 18. And then we can subtract 18 to get -12. So our original function g of t is 2/3 t to the 3/2 minus 12. And then last one here, we can integrate both sides and we'll get f of theta is negative cosine of theta plus c. And then 2 equals negative cosine of 0 plus c. So I always do the trig function first. So cosine of 0, it's the x value, so that's 1. But negative of that is negative 1. So c is 3. So my original function is negative cosine of theta plus 3. And again, I'll throw parentheses around that so that plus 3 is not with that variable. All right, and there we have basics of antiderivatives. So if you have any questions, let me know.